Hi guys, today we're going to look at section 2 from our chapter over igneous and sedimentary rocks. So the first thing I want you to do is just take a moment and see what do you already know about lava and magma. How are lava and magma alike and how are they different? If you would just pause the video and take a second to answer those questions in your head and then we'll go on. So lava and magma are alike because they're both hot, melted rock, also known as molten material. Sometimes you'll hear that word instead of lava or magma. They are different because magma is found deep inside the earth and lava is found outside on the earth's surface. So we're starting with magma and lava because magma and lava are what are used to make an igneous rock. So igneous rocks only form through cooling of magma or lava. Basically, when you have lava or magma hardening or freezing because it has cooled off, that results in an igneous rock. It's a common misconception that igneous rocks are formed from heating. The magma and lava would be formed when rock heats enough to melt. Igneous rock, however, forms when that magma and lava begin to cool. Here's a picture of the rock cycle that I drew for you guys, and we looked at it in our last video as well. You can see here is our igneous rock, and the only arrow that's pointing towards igneous is this blue one that says cooling, because the only way for an igneous rock to form is for magma or lava to cool and harden. You'll notice that there are several arrows leading away from igneous rocks because igneous rocks can be changed in many different ways. Igneous rocks are classified based on two primary things: their mineral composition and the location that they form. The mineral composition is what those minerals that are making up an igneous rock include. Mineral composition is usually classified into dark and light in color. The location of formation is two words that are probably new to you: intrusive and extrusive. I want us to look at each of those words. Extrusive igneous rocks are rocks that form on the outside or the Earth's surface. Extrusive sounds a lot like the word exit, which leads you to outside. Because extrusive igneous rocks are formed on the Earth's surface, they are formed when lava cools and hardens. Because lava on the Earth's surface cools and hardens much more quickly than it would inside the interior, there is no time for mineral grains and crystals to form. So you can see when you look at these examples of extrusive igneous rocks, it looks uniform throughout and there are no crystals. Intrusive igneous rocks, intrusive, inside. Intrusive sounds a lot like the word inside. And when intrusive igneous rocks form, they form when you have magma deep inside the Earth's surface, cooling and hardening. Because these rocks are forming deep inside the Earth, the magma cools much slower and gives time for individual mineral grain crystals to grow and form. As you can see in this picture and this picture as well, you can begin to see individual crystal grains. Last week, you guys had the rock cycle assignment, and this is one of the images that someone shared with me, and I thought it was a great image, so I added it to our slideshow. This gray line in the image represents the Earth's surface, and I thought it was a really neat image of the rock cycle because everything below the gray line is showing you processes that take place inside the Earth, and everything above the gray line is showing you processes that take place on the Earth's surface. I especially liked this for igneous rocks because it shows the magma cooling to form an intrusive igneous rock. It would have been better if it would have shown some lava cooling to form the extrusive igneous rock. The second part of today's section is over sedimentary rocks. Sedimentary rocks involves a lot of definitions, and these are in your vocabulary that you are going to have a test over next week. I want to go through these words and make sure you understand them. A sediment is just a broken piece of rock. This can be anywhere from the size of a boulder to the size of a small grain of sand, or even smaller than that. Weathering and erosion are words that you should have learned in elementary school, and when you talk to someone in just casual conversation, they usually use these words together. However, a scientist will separate them into their exact meanings, so we want to make sure you understand that. Weathering means to break rock, and erosion means to move that rock. So you commonly hear those two words together because when we talk about, for instance, a wave or water moving, weathering the rock, when the water hits the rock and breaks a piece off, it is weathering it. But that water is also going to cause erosion as it takes the sediment with it. Deposition is usually a new word once you get to middle school. That one's not discussed as much in elementary school. And deposition is when we have dropping off or piling up of sediments. So where the wind or the water or whatever agent is causing weathering and erosion, where it drops off the sediment, we have deposition. Now, all of those depositions deal with sediment. These last two actually deal with sedimentary rock. So I want to make sure that we understand that real quick. Okay. Weathering, erosion, and deposition are shown by the green arrows on our diagram. Any type of rock, metamorphic, igneous, or sedimentary, can be broken and changed into smaller pieces of rock known as sediment. Sediment can also be broken into smaller pieces. Sediment, however, is not a sedimentary rock. Sedimentary rock formations are formed from this arrow when we have these two C words taking place, compaction and cementation. The word compaction means to squeeze or press together, like a trash compactor would squeeze trash together for you. Cementation means to glue or bind together. A way to remember that might be to think of cement, like on a sidewalk, gluing and binding itself together, or rubber cement is a type of glue. So sedimentary rocks form, like in this picture, when over time layers of sediment are placed down. The ones on top are pushing or compacting and causing those mineral grains to become closer and more compact together, or through the process of evaporation, where water is leaving these behind and gluing them together. So we have sedimentary rocks are formed through compaction and cementation. Because we live in the state of Kentucky, I like for us to look at how coal is a sedimentary rock as well. So here are some pictures of coal and a chart that shows you how coal is formed. Going from the process of the organic matter being compacted, and cemented, there's the evaporation taking place, to begin to form the different types of coal: lignite, subbituminous, bituminous, and anthracite. So this is a sedimentary rock that's forming because of compaction and cementation. I'm probably not going to put specific questions about the types of coal on there, but because of where we live, I wanted to make you aware of it while we're studying this unit as well. The last thing that we're going to look at is the fact that the majority of all fossils are found in sedimentary rocks. So fossils are any naturally preserved evidence of life. And we do find fossils in places other than sedimentary rock, like amber, which is tree sap, or frozen, such in glacials. But a vast majority of fossils that we find are found in sedimentary rocks. We don't expect to find sedimentary rocks in igneous rocks because when we have our melted magma and lava, any evidence of life would have been destroyed at those high temperatures. We rarely find them in metamorphic rocks due to the heat and pressure that is exerted on those as well. So fossils are any naturally preserved evidence of life, and they're primarily found in sedimentary rocks. Now, why are we so concerned with fossils that we find in sedimentary rocks? For many reasons, but the main one is that they give us a glimpse into what life might have looked like at another time on our Earth. They give us an idea of what organisms looked like and where organisms lived, which is really important because we didn't have cameras to capture these images. Okay, guys, today's notes are over our two types of rocks, igneous and sedimentary. We'll join together on Friday to discuss metamorphic.